Hello, I am Ramohan, working as head of department at the Government Polytechnic, Mahbub Nagar. The topic now for us is the resistor, and the subtopic we are looking into will be the specifications of the resistors. The main objective on the completion of this lesson, you would be able to understand the specifications of the resistors, the importance of the specifications, why they are important at the time of designing or for which application, and so on. Let us recap some of the topics we have learned that are relevant and useful for the topic we are going to look into. What is a resistor? It is a passive component that opposes the flow of current. For what purpose the resistor is used in the electronic circuit? It will be used to limit the current or reduce the current that is flowing through that arm where you are connecting in series of that circuit. Okay, then it is also used to provide the voltage drop, so that the drop across this particular resistor will be fed or applied to the next circuit that is in sequence to that. Now let us see some basic specifications of the resistors that are minimal required for any application. First one is the resistance value or the ohmic value, then the power rating or the wattage of the resistor, and the tolerance of the resistor. Let us look into the more important or specific specifications that are actually useful for higher end applications. And one of that is the stability of the value of resistor, then the size, shape, and also the leads design, how you need to connect onto the PCB, then the electrical noise that it is going to introduce into the circuit, then the temperature coefficient of the resistor, and the voltage coefficient, and also the high frequency performance. That means how it can withstand at high frequencies, whether it is going to act like a resistor or something else like a capacitor also. Now let us see the basic specification, that is the resistance value. So this indicates the value of the resistance in ohms, and most of the time that is printed on the component depending on the size of the body, or it may be color coded on the body as you can see in the figure. Okay, then the general values available are 1 ohm to many mega ohms. So in the figure you can see the color code, and that is amounting to about 2.4 mega ohms, and the tolerance is 10%. That means it is silver color over there. Now let us see the next specifications, that is power rating. It indicates the maximum power that a resistor can handle or it can withstand. Okay, this determines the maximum current that a resistor can withstand without getting destroyed. Okay, so you can see in the figure, destroy means what? It gets burned when you exceed the current that it can handle. So 0.1 watt to hundreds of watts are available in the market for different applications. So we'll also see, now here we can see the different wattage resistors. So the first one is 0.25 watts, means they are called as normally quarter watt resistor, and the size is about 6.3 millimeters. And you can see the next one is a half watt resistor, the size is about 9.2 mm. And we can look at the first figure, which is burnt blue. It is, there is a scale near to the resistor, and it is measuring about less than half an inch. The length mark is half, so it is less than that. That means this one 9.2 mm. Then you can see next one is a 2 watt resistor, and the size is about 14 millimeters. Then there is another one that is high wattage resistor, that is 11 watts. So normally they are not much required nowadays, but for high end applications like power control and all, we will be using these high wattage resistor. Can you see the size of that resistor? It is about 9 mm into 9 mm, that is a square, and the length is about 50 mm, that means 5 centimeters long. And here one common thing is the leads are all cylindrical type, wire type leads. Okay, right. Now let us see the tolerance. This indicates the deviation in the resistance value from the rated value. It is expressed in percentage. We have learnt it. And normally the tolerance values range between 1% to 20%. The value printed on that or coded on that. So in the example figure, we can see that the color code is red, violet, green. So this is the value of the resistor. That means it is 2 and 7 multiplied by 10 to the power of 5. It is green. So what is the value? It is 2.7 mega ohms. And look at the tolerance, it is gold, 5%. Now let us look at the next spec, that is stability. It measures about the consistency of the resistance value in the different atmospheric conditions. Okay, the stability refers to the value of the resistor without getting changed in different atmospheric conditions. Like atmospheric conditions means like the temperature and the humidity. Okay, now let us see the different specs, that is about the shape and the leads. There are different models available for different applications, like different shapes. So you can have some rod type, disc type, and washer type. The first one is rod type, middle one is a disc type, the third one yellow color is a washer type. The different leads available are axial, radial, or lugs. Now let us see into the electrical noise. Here this consists of small fluctuations that are superimposed over the actual IR drop, that is the current into the resistance value of the component. This refers to the electrical noise because it is in terms of voltage. So the other one is the thermal or the Johnson noise. The next one is the current or the contacts noise. That means when the soldering is not proper or to the PCB, that results in variations in current. That is called as contact noise. Thermal is when the temperature is varying on the component because of the flow of current. The temperature of the resistor will vary. So that leads to some variations in the IR drop of the resistor. So this is the electrical noise. Now temperature coefficient. This indicates the change in the resistance with change in the temperature. Now voltage coefficient. This indicates the change in the resistance with change in the applied voltage across the component. That means when you use a particular resistor at small voltages, it may be fine. But when it comes to applying or working at the higher voltages, there may be some difference in the resistance value. So this refers to that. The reasons are many for that, the design constraints and all. It is the measure of non-linearity of the resistance with respect to voltage. Now next one is the high frequency performance of the resistor. Resistors are basically frequency insensitive, but at very high frequencies the capacitive and the inductive effects change the value of the resistance. So in Byron there will be some inductive effect due to frequency, and depending on the length of the component there will be capacitive effect at high frequencies. So let us see at the importance of the specifications, why they are important. The specifications help us in choosing the suitable resistor for the different applications. And how the applications are divided. So basically the component or the applications of these electronics are widely divided into three areas. That is military applications, which requires very high quality and high stringent working situations or environmental conditions. Then commercial applications, they need reasonably good quality, like our TVs, computers, electronic appliances at home normally. Then ordinary entertainment, they need low quality components. The military requires high quality because the military applications can be in a normal environment or at high altitude, high temperatures, like in Rajasthan deserts, and very low temperatures even in minus at some Himalayas, etc. So let us summarize what we have learned in this lesson. To choose a resistor for any use, we have to look at the specifications of the particular resistor. The basic specifications of the resistors are only three. That is the resistance value, the tolerance, and the wattage. The other specifications that are also required to be looked into for an application are the stability of the value, then the electrical noise it can introduce, the temperature coefficient, the voltage efficient coefficient, and the high frequency performance of the component. Then based on the application also, we have to choose a resistor of appropriate applications, like for military or commercial, like we have seen in the previous slides. Now let us see or check our memory capacity by looking at the small quiz. Which of the following specifications is a basic specification of the resistor? Stability, resistance value, electrical noise, or the temperature coefficient? Which one? It is the stability resistance value, right? Now let us see some frequently asked questions that might appear in an exam depending on the topics we have covered now. The first one is state the importance of specifications of the resistors. why the why they are important. Now next one is list and explain the various specifications of the resistors. We can work on an assignment like this. You can take any 5 different types of the resistors in the lab and write down the specifications from what we have learned from.